Okay, we've been looking at domain and range, continuous versus discrete. First off, when we talked about it, we said that domain, the variable for domain is x, the variable for range is y. So if I had a graph, a lot of times you'll see it in the first quadrant, because when you're talking about situations, and we're going to talk about the difference between a situation and a function as well. A lot of times when you're talking about the situation, if you're talking about numbers that we deal with here in our everyday life, where you're talking about positives. So that's normally why there's the first quadrant. We'll get back to that in a little bit. But remember that we've got the x, which is the domain, and the y, that is the range. Let's remind ourselves as well, what else do we call the domain? Starts with an I. It is the independent. So the range is a dependent. There's one other word that we used. Started with an I again. You had that little funky machine where you input. We have X is the input. Y is the output. Okay, so let's see here. Oh, let's quit going back. There we go. Suppose a thunderstorm is approaching your home. Currently, the storm is 175 miles away, but is moving towards you at a rate of 25 miles per hour. To represent this situation, we can use the equation y equals 175 minus 25x, where x represents the number of hours and y represents the distance of the storm. Now, I want to point something out. Whenever we asked, like on quizzes and tests or on other sheets before, when we asked you to define your variables, that's what the problems are doing right here when you get them. Anytime you have a word problem, they're always telling you what x is and what y is. That's what we want you to do when we ask you to define your variables. Okay, so right now in your paper, because I'm probably going to turn it up at the top, don't use the whole paper that you have. On the blank side, put y equals 175 minus 25x. Okay, give yourself room to be able to write. And I am going to bring up my handy dandy calculator. All right, so if we look at this, it gives us the problem, and it wants us to complete a table and a graph for the situation. So I want you to sketch on your paper the table. So build this table right here. Not real big, but just enough to be able to fill in 0 and 175, 1 and whatever. And you're going to be able to fill in your table, you'll go to y equals in your calculator and put in there 175 minus 25x. And then you'll be able to go second graph and look at your table. Let's see, I need to go back to 1 or 0 here. Okay, so now with this information, you should be able to fill in your table like I'm asking you. So what you should have been doing is looking at this, and it says 0 and 175. That's what's already in your table. 1 and 150. So I'm going to put in there 150. Looking again, 2 and 125. You would have seen 3 and 100. What is it decreasing by? 25. What is actually happening with this storm? It's getting closer to you. How long is it going to be till the storm reaches you? It's going to be 7 hours. Now, it wants us to graph it. And up here on mine, I wish I could figure out, they changed things around. I don't know where my handy dandy little dots are anymore. Okay, I'll quit looking. All right. So it wants us to plot 0 and 175. So I'll go up here. This is my starting point. That's the initial point where we're finding our value. That's our constant. 1 and 150. Bless you. 2 and 125. 3 and 100. 4 and 75. 5 and 50. 6 and 25. 7 and 0. Now I plotted the points. We talked on Friday about discrete versus continuous. Do I leave these as dots, or do I draw the line and connect the dots? You leave them as dots? You draw. Why are you saying why draw the line? Because it's saying from 0 hours to 7 hours, the storm is getting closer. Yeah, does it automatically jump like from 175 miles to 150? Like poof, it just like a magic, like Wizards on Waverly Place, right? Just poof. No, it gradually gets closer and goes through every little bit. So is that discrete or continuous? That when it is a line that connects all the way through, it is a continuous graph. Remember, continuous does not mean that it goes on forever. It means that it goes through every point, every number between 2 points. Like 0.9, 0.99, 0.9999999. Okay. Let me go on. Oh, I got to move. Oh, why'd it come back? Don't come back. Go away. There we go. Yes, because the data is continuous. Now, it wants us to talk about what is the domain for the situation. Remember, domain is the x. So, take a minute and try and guess. Oh, and the range is the y. Take a minute and try and figure out what you would write for the domain and the range for this situation. Write it down on your paper. First off, up here on my table, remember this, the horizontal axis is the x, the vertical is the y, which means the number of hours is the domain. Okay, so number of hours is domain. From, oh, not from, what does it start at? Yeah, from 0 to what? To 7. That's when the storm shows up. Now that's one way to write it. That's kind of how you could write it in words. Oh, come on, friend. There we go. So you can also write all real numbers between 0 and 7 inclusive. Let's talk about those words real quick. All real numbers. Somebody said, is there really, what are there fake numbers? No, there's not fake numbers. There's imaginary numbers. That's why they say real numbers. Imaginary numbers you'll learn in Algebra 2. Inclusive means equal to. That means it includes 0 and 7. That's why down here there's an equal to bar. This down here in set notation is what I want you to have written down on your paper. It has a little squigglies. It has a smaller number to the left. And then less than or equal to x. Less than or equal to 7. Now the range, remember the range goes up and down. So in this case, there we go. It's all real numbers between 0 and 175 inclusive. It's every number between 0 and 175, including those numbers. And again, you have your set notation. The smaller number zeros to the left, less than or equal to y, less than or equal to 175. Now, it says, suppose you're asked to graph the equation And it gives you the equation. This is important for the difference in the problem. All it's saying in this case, forget about the storms, forget about the hours, miles, any of that. It just is giving you the equation. And it says y equals 175 minus 25x. So they want you to graph it. Well, if I put it in the calculator down here, and I go to graph that, in the calculator, when you go second graph, oh, I'm already there. When I go second graph, in the table, they have all kinds of positives and negatives, right? And if I wanted to press graph, now I'm not going to see it because it's too high up. Let me see if I can zoom out here. Oh, there it is. There's that right there. Let's see, zoom, 3, enter. The graph shows it going all the way down into that fourth quadrant down here at the bottom. Because all it is just an equation. It's not putting it to any kind of situation. So here's what so in the calculator when it asks what is the domain, does the calculator go through and stop at any numbers? It goes forever and ever and ever and ever, ever negative and forever and ever and ever positive. What do we use for forever and ever? Think of Buzz Lightyear, right? To infinity and beyond, right? Yeah, it's like that that sideways 8 looking thing. Okay, so to reveal your answer, come on. All right. For your domain, you can write all real numbers, or you can write negative infinity, less than or equal to x, less than or equal to infinity. Those two things mean the same thing. Now the range, when you go in the calculator and what kind of numbers does a y number have, again, it's all real numbers. The calculator does not know the situation. There is no situation in this case. All they're asking you to do is put they were saying, hey, if I gave you this equation, what are my possible x numbers? What are my possible y numbers? Well, if it doesn't have a situation to it, it could be any of the numbers if we went to go graph. So when they're asking you to complete the table here, I mean, when you're talking about it, you've got like maybe -3, -2, -1, 0, 1, 2, 3. So I know that this is 175, 150, 125, 100. Now I only know this right here because looking at the calculator, if I keep going back up, here's my numbers. I can look in the calculator and find those numbers. So when they go to graph it, like the funky graph, that's their picture of a graph. Come on, little man. Here it is. Choo-choo. Okay, I don't want this to do anything. When you go to graph it, it's just going to give you the line that's right there on the graph. So I just go through and, where'd my line go? I'm not being exact, but it's somewhere through here. I know it goes through 7, 0. Now what it wants us to do is look at and see and compare. It's the same equation, but the domain and range and tables and graphs are different. Why? Because see, if you look at it, your equation right here, if I went to graph it, this is what the calculator has. But if I talk about the situation, it only has this first quadrant. Why is that? Because that's how much distance the storm is coming. Well, what's wrong with this one down here at the bottom? Why couldn't we use that one, that graph, to represent the situation? You don't need all of them, and because all of this down here is what? Oh, I didn't mean to draw a line. All of these are negative numbers. Can a storm go negative miles? Can there be negative hours? No. So when you apply it, you take an equation and you apply a word problem to it, that's when our graph changes. That's why in the situations when they apply it to a word problem, you have to think and reason in your mind, what type of numbers do I use, and can I use any others? And so the domain and range has to stay up here between 0 and 175. That's the range, I'm sorry, and the domain from 0 to 7. Because after 7 hours, that would mean that the storm has actually gone past you, but you're talking about how many miles it gets to you. Okay, domain and range of a situation are often different than domain and range of an equation. The situation restricts the x and y values that can be used because the values must make sense for the situation. And that's what I was trying to say by you can't have negative hours. On an equation, it says without a situation, any x and y value can be substituted into the equation, including all integers and all rational numbers. Because anything that, if it's an equation, any number will work. Okay, so now turn your paper over. You've got this right here, and it says both sides of domain and range. Now, it gives you the word problem. It says, at the start of the school year, Ms. Dorval purchased 4 pencils for each of the students to use in algebra class. She also buys a box of 50 extra pencils for emergencies. So it's asking you to write the domain and the range of the situation and describe what the graph would look like. And then down at the bottom, it gives you just the equation. And how is that equation, what does that equation look like compared to the situation? Hold on. So right now what I asked was for you to go into your calculator, into y equals. I need to turn off my pen here. Go into y equals and put in there 4x plus 50. And press second graph. Now I asked, in the calculator right here, when you're talking about domain is x. Does it stop anywhere? Like, when I press the buttons going up and down, does it stop? It keeps going on forever and ever. The domain of an equation is always going to be all real numbers. Okay, because in the calculator, it gives you every number and every decimal if we really wanted to look through and see on any kind of equation. With the range, it is the same thing. It's going to be all real numbers. Oh, did it not put that in there? Nope, it didn't. Okay. So now down here, we're going to start down here with the equation. When it says describe the graph. Well, draw my line. Oh, the graph is over here. On the graph, I know that my y-intercept, my constant is up here at 50, because when you go and look in the calculator, it starts up here. And when you press the graph, darn it. All right, come on, bud. There we go. My line is increasing, and it's going up from left to right. Well, when I describe my graph, it's increasing, it's continuing, it's going on forever and ever. It's going on both ways. So my line is increasing and going through all the numbers on that line. Then if I look up here, when we talk about the actual situation, if we're talking about, so this down here, I'm sorry, I should go back down. This right here, this function, this is continuous in this case because it's every number, every decimal. If I talk about up here, we're buying pencils. She's buying pencils. And for my domain, if I go and I have it in the calculator, let me just write a little X and Y. If I talk about pencils, can I have negative numbers in my X column? Why not? Yeah, you can't buy negative pencils. So I have to start with what number? 0. I start with 0 because she buys a box of pencils before, and so it's a box of 50. For every student she has, how many more pencils does she add? She adds 4 more pencils, so this will be 54. 2 will be 58. Let's see, is that what it says in the calculator? Sure does. So on my, when it asks me what is my domain, I could do this a couple ways. I could write from 0 to, and I'm going to put a reasonable number. She's not going to have 100, like 300, 500 students in there. Or I can write, another way I could write my domain is all positive. Talked about the fact you can't have them in negative pencils. Whole numbers. Because you can't buy a half of a pencil. Or an eighth of a pencil. Or 0.99999 of a pencil. Now my range, what does my range start at? From 0, not 0, sorry, no, you're right, 50. I didn't mean, because the first box has 50 pencils. So from 50 to a reasonable number. So another way I could write that is I have my R equals my range. I use set notation. 50, comma 54, comma 58, and then sometimes you just put dot, dot, dot because it goes on forever, or goes on into a reasonable amount. But on this graph right here, I wouldn't even use these quadrants right here. I would only use quadrant 1 because I have to have positive numbers. So I would start at 50 and put a dot, and for every for every 1 student, it goes up 4. So my graph of this would be discrete. Because you can't purchase, whoops, I didn't spell discrete right either. Because you can't purchase 0.9999999 of a pencil. So if I describe my graph is going to be dots, points in the first quadrant. Remember, your quadrants go 1, 2, 3. Whoa, one more extra line. Sorry, that's not 4. That's not even a 4. 3 and 4. Like that.